I'm just about ready to pop in all the tubes, hook up a speaker, and power this radio up fully for the first time. But before I do that, I want to try powering it up without that interlock being in place. So we're just going to have power up to this point. Well, the problem is I don't have a 5Z3 rectifier tube, which is basically a 5U4 with a 4-pin base. So I could either rig up an adapter or use one of these guys, which is a solid state replacement. Basically 2 diodes potted up with a 4-pin base. And I've already got one popped in here. My downside to this, well, 2 downsides. One is it instantly turns on. Although these rectifier tubes power up pretty darn quick. They heat up faster than the other tubes, so generally you get power here very quickly anyways. But there's also no voltage drop, or very little, like 0.7 volts. Well, what I've done is thrown in a CL80 thermistor. I'll probably need to add more resistance, so this will provide a bit of a soft start. These are about 120 ohms cold resistance, and as they warm up, the resistance drops off. Although if I had a wider selection, I'd use one with a lower current rating. These are rated, I believe, for 2 amps. That doesn't just mean it can handle up to 2 amps. That means it's designed to run at around 2 amps, meaning that if you have less current than that, it doesn't reach its optimal temperature and the resistance doesn't drop off fully. Like if you're only drawing, say, 1/10 of that or less, which is what I expect this will draw. This will probably run pretty cool. And if you look at the data sheet, it's kind of unpredictable what the resistance will actually be at low current rating, so I should use something like a CL80, something with a lower current rating. Anyways, there was already a break in the wire here, so I just took advantage of that to tack in some components. That break is actually right here. So what I've done is, that's where I stuck in my thermistor, and on the other side of it I put in that filter cap, which would normally be located way up here. And the wire that was running up there had been cut off. It was down in here and clipped off. So I'm going to run a new wire up here later once I get this thing running. Now if I just did that with this out, there's no load. So not only would it not be simulating the radio drawing power, but it also would leave this capacitor fully charged when I turn the radio off. So I tacked in some bleeder resistors, a couple 20 watts in parallel, so we got about a couple 20K in parallel, so 10K load on that. So if I power this up, if all goes well, we should have a B+ voltage here. It's in the ballpark of what they say, which should be 480. And I've hooked up to a Variac, dialed down to 110 volts AC. I expect we're going to get a bit higher than 480, so because I don't have the internal resistance of the 5Z3 rectifier, so we'll be adding more resistance. I'm guessing 47 ohms, somewhere in that ballpark. But for now, let's just make sure this works. So, get my voltmeter powered up here. It's right across the filter cap and the bleeder resistors. Variac's on, so let's give this a try. Oh, cool. 512 volts. So, set a little bit higher than 480. But things seem to be holding steady. And my pilot light's lit up. So next up, populate all the tube sockets and rig up a speaker. Still haven't repaired the speaker that came with this, so I'm going to use in the meantime is this RCA. Need to patch up the cone a little bit and hook up some wires the same way Stromberg is. So here are the 2 field coil wires, and here are the 2 voice coil wires. I used a little bit of diluted Eileen's tacky glue to repair the tears in the cone. Nice and solid now. And then I dug up a dead 6-pin tube, broke the envelope, cleared out the glass and internal structure, and made myself a new cable for this speaker that matches the old one. So we've got the interlock, 2 red wires are the voice coil, and the purple and the yellow are the field coil. And that plugs right into that socket. So now all that's left to do is a little bit more wiring. Need to hook up the output transformer and run the output over to this. Now this output transformer, which I got mounted up top here, has multiple taps, and you're supposed to choose the proper output taps for the field, or the voice coil impedance, which I don't know, so I'm just going to guesstimate. These tend to be fairly low, so I'll use maybe the 4 ohm tap and see how that goes. Need to clear this out a bit. I won't need these bleeder resistors anymore now that I've got the interlock and field coil in place. It'll energize the rest of the set, which leaves popping some tubes into place. Oh, and the rebuilt electrolytic capacitor block. So getting really close. Okay, here it is. All the tubes popped back in, and the caps. And for the output transformer, I'm guesstimating 3.2 ohm voice coil and around 10,000 ohms on the class AB push-pull triout outputs. So that would be 2 and 4 for the terminals there. Seemed like a reasonable thing to choose. So I'm going to get ready to power this up. I want to put this thing on its side when I do, though, because, well, you'll see why in a moment. This is the reason why I want to keep it on its side. I put a 100 ohm resistor in series with the B plus right after the rectifier tube, and I kept the thermistor in there. If I put the chassis on the bottom, this kind of gets smushed down to my short to something. So I'm going to get out my voltmeter, and for now I guess I'll connect it up right here so we can monitor that when I turn this on. And well, I mean, I'm nervous. This thing required a lot of work. There's some guesstimation on these transformers, but hey, there's only one way to find out if it's going to work or not, and that's just to give it a try. Okay, radio off, PR57 on, and radio on. That's encouraging. Tubes, yeah, tubes are lighting up. Turn that down for a second. Notice it was negative because I realized I have these connected backwards. Get those out. So, sounded pretty horrible. Loud hum. But nothing went up in smoke, and the B plus didn't crash down. Resistor's barely warm. This resistor is a little bit toastier. I think next I'm going to check the voltage. Let's see, try to find the main B plus, which would be after the field coil. Top of this resistor, but I have that lug insulated there, so it's not so easy to tap into, but I'll trace it out up here and hook that up. I was trying to adjust the volume control, and that really didn't seem to affect the hum coming out of the speaker. I was poking around checking voltages, and things seemed reasonable until I got to this lug on the capacitor block. I actually got a negative voltage there. And considering these caps are with respect to ground, that should definitely be positive. It was only negative like a couple volts, but that sure didn't seem right. And then I noticed there was a lug, or a wire going to it that's no longer connected to anything. So I think I best check that out. Something else odd is some of these other lugs had very low voltage on them, which also didn't seem right. Although that might be okay. I used like 450 volt caps throughout, but some of these like this 8 microfarad here. It's a cathode bypass in the 6A7, so it's probably really only going to be a few volts on that cap. So I probably did gross overkill on some of these, but it certainly shouldn't have a negative voltage. So what goes to that lug? Well, let's trace it out. That's at the 3 o'clock position. So it's this guy right here. And not surprisingly, one of them used to go to that transformer, which is the one that's missing and no longer there. So that explains that wire that's going off into nothing. But what about the other two? What did they go to, and why is there no voltage on them? Or why is it slightly negative? I traced out that cap, and it turned out to be this guy. This transformer is no longer there, which explains the wire that was just hanging off going to nowhere. Now if we look around, see what that goes to. It goes to this resistor, which goes down and around over to here. Now these are negative voltages. This is ground. And the center tap of the B plus does not go to ground. It goes through these two resistors and then to ground. So this develops a negative voltage, which they use to bias tubes. So it makes sense there's actually a negative voltage there. So I disconnected my resistor, or capacitor block rather, and flipped one in going around the other way. And I started playing around with the radio a bit more and hooked up an antenna and check this out. Still a horrible hum, but I can actually hear some sound now. So there's the horrible hum. Turn the volume up. Control sound.
In account of CIA Director John Brennan, and also breach of account
The tone control seems to be very dirty.
says he's not surprised by the breach. We do know this for a fact.
I'm curious to see what effect this switch has now too. I believe that's this switch right here, which I think is also acting as a type of tone control.
Government aviation correspondent Romain Marsh says there are still a couple of key questions that need to be answered.
What kind of personal information?
Question is, where is that god-awful humming coming from? I wonder if it could be as simple as the 42 tubes I'm using are just horribly unmatched.
11 o'clock, I'm Tom Johnson, 80.
Commercial sector across technology and pharmaceutical industries that we have reported.
Well, I think I can see why we've got some serious hum issues. I'm looking at the power supply and we've got a serious amount of hum. I'm showing 93 volts AC right off this primary cap here. And let's see further downstream, like here. The meter's having a hard time even figuring it out. And if I look on my scope, even on the highest range, it's just right off the scale. So it's like there's no filtering action whatsoever. Now, there's no question the 1.3 microfarad is in play, as is this choke. And since the speaker's working, there's got to be power going through that field coil, so I got to figure there's something up with these caps, that they're not in there right. So the first one I want to check is that guy. The 16 microfarad, to see if it's installed and hooked up properly. Okay, I think I found the problem. And it's more minor than I was worried about at first. So when I was building up this capacitor block, I knew that I had to do this while looking from the socket side. Like the top there is ground. In other words, I couldn't put in the caps like this. I had to put them in so they matched up like that. And they are for the most part. So like there should be 8 microfarad, 8 microfarad, and 4. And if you look, it's 8, 8, 4. But the one I got wrong was 16, the main filter cap. I got it going over between here and here somehow, and it should be going over to that side. So, and I think I might have this 4 and this 8 kind of screwy. Well, no, the 8 is right, but there's something not quite right around here, and I think it's just that this needs to be rotated 180 and going over to this side. That should be easy enough to try out. Okay, that was easy enough to do. Just heat up the pins, pull out the cap, flip it around, stick it down into the right hole. So let's give this another try. That's better. Still a home. Way less.
U.S. News and World Report also ranked ASU in the top.
Yeah, just barely a home.
And learn to thrive with Arizona State University.
Now, of course, I haven't gone through and done an alignment or anything, but it seems to be working all right, just as it is.
When they won the World Series. Got the Florida Panthers at the United Center. Only game played in the NHL by a score of 4-0.
So my guesstimation on these values seems to be okay. So what did I go with? Well, I went with a 56K resistor here, and I put a 220 in parallel with this 100K, and I used a 0.1 microfarad cap here. So that seems to work okay. The driver phase inverter transformer seems to be working okay, as does the output transformer and the non-original speaker. Now these circuits are pretty forgiving, and I may tinker around a little bit, especially on those resistor values, like that plate resistor 56K. Try using a 100K and maybe a 22K and see if I notice any difference.
Old. And
let's try the other band. Oh, there's a whole lot on this band these days. The band right above the AM band. So this is just picking up the top end of the AM band, and then above that. Yeah, not much to hear. Oh, there's a good old time station.